Okay, 5.8 solutions to quadratic equation. Basically today's lesson is kind of a review, which is good. We've just come through now the third method of solving quadratics, right? So again, you see a quadratic, something squared, variable squared. You're thinking two solutions, and you're thinking three ways to solve. So two solutions, three ways to solve. One, take the square root of both sides. Two, factor it, setting equal to 0 and solve. Or three, use the quadratic equation. Okay, so what they want you to do here is to choose the Beth methodology. Again, in the powers that be's mind, even though the quadratic equation solves everything, it's not the best method, or should I say the quickest method. So in their mind, you shouldn't just solve every quadratic using the quadratic equation, although you could. They want you to be aware of solving by factoring and solving by taking the square root. So in reality, if you have a choice, the first thing to look to do is to take the square root of both sides. Take the square root of both sides. So that's the first thing you want to look to do. Oh, and solving quadratics by the, quote, best, unquote, method. So take the square root of both sides. Remember, you can only do that per se when there's no variable to the first power, right? You got the variable squared, you don't have a variable to the first power, then you can take the square root of both sides. Or if it's in the special form, where the quantity squared contains the variable. Technically, that has a first power term, but because the whole quantity is squared, you can take square root of both sides. All right, second is factoring. And third is the quad equation. That's an ugly Q. All right, the quadratic equation. So nothing earth-shattering there, just basically a review. They want you to go through and take a look and try to determine which way you're going to go. So when you look at a problem like this, first off, you're going to say, can I take the square root of both sides? And the answer would be, it should be no. So, and the reason no is because you have a, you have a variable to the first power, right? So because of that, taking the square root of both sides is out. Therefore, honestly, almost every time, then the next thing is you're going to try factoring. I mean, you're going to try it. Now, for some of you, factoring takes you a while. So unless you're told to factor and you're not a good factor, you might want to just go to the third method and use the quadratic equation. But again, sometimes you're going to be told solve this by factoring, then you're going to have to. So let's see where we end up here. See if it even factors. All right, you got to get that -2 on the other side. So now we know the front terms have to be 3x and x. All right, hopefully you agree, 3x and x. Now we're looking at the back, and the whole time we're looking at -8. We've got -10x in mind, right? So I got to add up to a -10. Oh, I see it already. How about a 4 here gives me a 12, right? And the 2 here is going to give me a 2. A 12 and a 2 can give me a 10, right? But again, I'm looking at my middle, and my middle needs to be negative. So I know I want the 12 to be negative and the 2 to be positive. That's going to give me my -10 in the middle. And factoring. That should be your thought process. Okay, just for clarity's sake, normally I would just solve this first equation. But remember, you set it equal to 0 and solve, right? It's a little equation now. Because of the zero product property, if you have a bunch of things multiplied together that equal 0, one of them at least has to be 0, right? So move the 2 and move the 3, and you get -2/3, right? -2/3, right? And then the second equation is real easy. You move the -4 to the other side, you get x = 4, and those are the two solutions. And that wasn't too bad, and onward, forward. Shout aloud, Hosanna. Solve by factoring. Second example off here to the right. Got a first power term, so we're not going to take square root of both sides. Agreed? So again, we're going to look at factor. Does that factor? Does it factor? Does it factor? Some don't know. I don't know why this format gets students for some reason, but not only do you want to factor out the common 2, on this one you want to factor out the common x. It really makes life quite easy. And you're left with x plus 4. And look, from this x can be 0, right? Because it's a factor. And from this x plus 4, x must equal negative 4, and those are your two solutions. So again, you looked at taking the square root of both sides. You ruled it out because of the first power term. Therefore, then you went to factoring, and it does factor. Third situation, first power term again, not going to take the square root of both sides. Going to move the 4. So let's move that 4. So you got 3x squared minus 4x plus 5 equals 0. And 3x squared in the front's got to be 3x and x. Okay, be careful on the back terms. You can only use a negative times a negative. Agreed? And the reason is it's a plus 5. And if you use positive times a positive, you'll never get a negative 4 in the middle. So we know it's got to be negative times a negative. And there's only one choice, negative 1, negative 5. And I can either put the 5 back here and the 1 there, which gives me 15 and 1, and that'll never get me to 4. Or I can put the 1 here and the 5 here, which gives me 3 and 5, and that'll never get me to negative 4 either. So it doesn't factor. So therefore, then, you're using the quad equation, right? And again, if your factoring is where it ought to be, that should be about a 40-second, 50-second decision on the factoring. Some of you agonize over your factoring because you're just not sharp with it. You need to practice more. You really do. Man, your day and age, you can go on the internet, you can type in practice factoring, and a computer program will pop up that will allow you to practice factoring, tell you if you're correct, tell you why you're wrong, all that stuff. But, you got to get good at your factoring. Okay, so quad equation. Let's try to do this pretty quickly. X equals negative b. So it's negative a negative 4. Do you agree? Negative from the formula and a negative 4 from the b, so that's a 4. Plus or minus the square root of negative 4 squared is 16, right? Now be careful here. Minus 4 times 3 is a negative 12. A negative 12 times 5 is a negative 60. All over 2a, 2 times 3 is 6. Again, you guys will be writing your quadratic equation every time because you need to memorize it. Once we finish the chapter, you do whatever you want. On the test, if you want to just go ahead and do the problem, go ahead and do the problem. Just better hope you don't have it wrong. What do we got here? A negative 44. So you thinking imaginary already? Hey, if I'm thinking imaginary already, I'm already going to split up the denominator. Because I know I have to split up imaginaries. And do you see the 4 from the 44? Which means we're getting a 2 out. And of course, we're getting an I out. So this is 2 times the square root of 11 I over 6. Anybody, I mean, did you keep up with that? You follow? So again, we got a negative 44. I can take the square root of the 4 and get a 2. I can take the square root of the negative 1 and get the I out, leaving the 11 in. I'm splitting up the front, the 4 over the 6, plus or minus now the 2 times square root of 11 over 6, and of course you're going to reduce this thing, right? So what is this? 2/3, and this one is 1/3. So if you want it looking pretty, x equals 2/3 plus or minus the square root of 11 over 3i. Imaginaries always give you conjugates, Nate.
So once you see the negative 44 in the radical, then you know it has to be imaginary.
It has to be imaginary, yes. Negative radicand's always imaginary. Yep. Which then again triggers in, I've got to split this one up for the right format to finish my answer. All right, so quadratics. All right, so some of tonight, they're going to ask you what's the best method. And again, you just need to cycle through the choices. Square root of both sides, factoring second, and then if neither one of those is the best, that leaves you quadratic. Okay, number 2, type of solution of any quadratic equation can be determined by the value of the... All right, people, we are getting ready to discriminate. Did you hear me? We're going to discriminate. You hear that? We're going to discriminate. Oh my. Lions and tigers and bears. Oh my. We're discriminating. No! Not today. It's 2016. Mr. Scarfy. 15. You cannot discriminate. In 2015. You can't. We can. We can. We can. We need to discriminate. All right? Discriminate. And in our keen world of political correctness, that's a dirty word, and it's not a dirty word. And in math, we're going to discriminate, and we're actually going to figure out the value of the discriminant. D-I-S-C-R-I-M-E-N-T. Discriminant. Not the determinant. I think I spelled that right. Wait, I'm missing stuff. Discriminant. Discrim, C-R-I-M-I-N-E-N-T. I believe that's correct. The discriminant. Okay, determinant involves what kinds of things? Matrices. All right, that's different. The determinant is different. I guarantee when I ask you a short answer question on the test on Tuesday, some of you are going to write in the determinant. All right, it's not the determinant, it's the discriminant, because we're going to discriminate as to which type of answer the quadratic will have. That's why it's called a discriminant. So, discriminate. And it's simply which is I don't know why I have this blank when I have this. So don't do the blank, we'll just do it. It's the b squared minus 4ac of the quadratic equation. That box should be in the blank. So, first edition notes, oh well. Such is life. Oh, I know, because I probably wanted to say the radicand. That was probably my brain's thinking on that. The discriminant is the radicand. What's underneath the radical sign of the quadratic equation, the b squared minus 4ac? That's what it was. So we're looking at the radicand. Now, I have to tell you, I'm not a big discriminant fan. Because basically the discriminant tells you what type of solutions you're going to have to the quadratic. And to figure out what kind of solutions you're going to have to the quadratic, you have to get the value of b squared minus 4ac. If you're going to take the time to get the value of b squared minus 4ac, why don't you just do the negative b plus or minus the square root and the over 2a? It's not a whole lot more. I mean, b squared minus 4ac, all right, so you got to find that value. You're over halfway done to the value of the quadratic equation and solving the whole thing and getting the actual values. That's why I'm not a big fan, but the powers that be in math are big fans, and they expect students to know the discriminant. So because of that, I have to make sure that you're aware of it. But again, in my mind, by the time you figure out the value, you might as well just finish the whole thing and get the actual values to the whole thing. All right, so again, what is the discriminant? It allows us to discriminate as to what type of solutions the quadratic will have. All right, so let's cycle through the possibilities. There's 3 possibilities, and one has 2 sub-possibilities. All right, so hang in there. B squared minus 4ac is greater than or equal to 0. Or I could have said it was positive, right? Like if you get 1, that's positive. If you get 37, that's positive. If you get 82, that's positive, okay? So it's greater than 0. You get a positive radicand. Positive radicand. Therefore, you have 2 real number solutions. And the 2 real numbers can more specifically be these 2 categories. If the b squared minus 4ac is a perfect square, for example, 1. Now remember, this is the radicand, right? What's the square root of 1? 1. So you're able to take the square root and you get rid of that radical. Next one would be 4. Square root of 4 is 2. Next one would be 9. Square root of 9 is 3. Next one would be 16. Square root of 16 is 4. Next one would be 25. Square root of 25 is 5. You follow? All the perfect squares. So if it's a perfect square, you get 2 rational number solutions. Your 2 real numbers are rational numbers. We're being more specific. Do you follow? So if the b squared minus 4ac is a perfect square number, then we're going to say it's 2 real numbers that are 2 rational numbers. If the number is not a perfect square, for example, you get 7. Remember, this is the radicand. Can you evenly take the square root of 7? No. What kind of number is the square root of 7? I heard it. Say it. Irrational, right? Square root of 7 is an irrational number. So in this case, you get 2 irrational number solutions. So our 2 real number solutions are either 2 rationals or 2 irrationals, which are both real numbers. And that's what happens when your radicand, the b squared minus 4ac, is greater than 0. Let's take some time real quick and do these. Okay, b squared. 3 squared is 9. Minus 4 times a, which is 2, which is a negative 8, agreed. Minus 4 times 2 is negative 8 times c, negative 2. Negative 8 times negative 2 is a positive 16. Oops, shouldn't even have my square root symbol there. That's what happens when you try to go fast. Because all we care about is b squared minus 4ac. So again, let me slow down for a minute for you guys. This is b squared minus 4ac, right? b squared, 3 squared was 9. Minus 4 times 2 is a minus 8, times a negative 2 is a positive 16. Value of the discriminant is 25. What kind of solutions do we have? 2 rational. And sometimes the book wants you to say 2 real rational. Some will just say 2 rational. On the SAT, ACT, maybe the only choice will be real. So, but again, it's 2 real numbers that are specifically rational numbers. The second scenario, when you do b squared, you get 16. Minus 4 times 3 is a negative 12. Negative 12 times a negative 1 is a positive 12. In this one, I get a 28. Is 28 a perfect square? Therefore, the solution is 2 irrational. The discriminant. Again, in my mind, you're almost to the whole solution. Why don't you just get the actual answers? But such is life. They want you to discriminate. Of course, I'm sure the powers that be will one day eliminate the discriminant from all thought as they try to shape your minds. Okay, second scenario. B squared minus 4ac equals 0. I'm going to put it in quotes, one real number solution. One real number solution. Okay, there are really two, but they're actually the same root. So let me do it off to the side here. B squared minus 4ac. Both goes up here. Both solutions are the same value. So let's do the b squared minus 4ac value of the discriminant. 4 squared, right? I'm looking at the b value is 16. Negative 4 times the a, the 4 is a negative 16. Negative 16 times a positive 1 is a negative 16. Value of the discriminant, 0. Conclusion, 1 real number solution. And it could be anything from a natural number up through a fraction, a rational. So we just say real number. Hey, real quick, just to show you, if I factored this thing, if I went to solve by factoring, 2x, 2x, plus 1, right? Middle term will end up being a 4x, right? Correct factoring. Solve each quadratic, you get to this one, x equals negative 1/2. And again, you get x equal negative 1/2. Again, in reality, there are two solutions, but they're the same value, so we say there's one, right? Second scenario. So first scenario, you get a positive radicand. It means it's greater than 0. It's either going to be 2 real rational, if it's a perfect square, or 2 real irrational, if it's not a perfect square. Second scenario, it equals 0. The radicand equals 0. Hey, just think about this. What happens in the quadratic equation? Square root of 0 is 0. What's right before the square root in the quadratic equation? The plus minus. See how it wipes out the plus minus? Because plus minus 0 doesn't get you anything. It gives you the same value twice. You get the same answer. All right. If you can comprehend that, great. If you can't, don't worry about it. Just realize that when you get 0, it's one solution. Last scenario, you're less than 0. And remember, we're talking about the radicand. So if it's less than 0, you have a negative radicand, and therefore, it's what kind of solution? Imaginary. And again, technically, we're going to say 2 complex conjugates, because imaginary numbers are complex numbers. 2 complex, and they're always conjugates. So if we were to do the b squared minus 4ac of this example, we'd get 5 squared is 25. Minus 4 times the 1, which is the a value not shown, is a negative 4. Negative 4 times 7 is a negative 28. Final value of the discriminant, negative 3. And sure enough, we have 2 complex conjugates. And that's the kind we're going to split it up, because we're going to put it in proper form, a plus bi form, if we were solving the whole thing, discriminants. So when you guys are saying the type of solutions, you should show me the value of the discriminant. That's all I kind of need for the work. I don't need a ton of work. But give me something of how you're figuring out the number. That's the idea. Okay, last thing. What if they tell you to do something like this? Write the standard form of the quadratic equation if the solutions are x equals negative 4, x equals 7/5. You know, basically, what are we trying to do here? We're trying to find the factors that produce these solutions. Whoa. Find the factors that produced these solutions. Find the factors that produced these solutions. Okay, I've thought about, what's the easiest way to try to get you guys to understand this and see this And I don't know that I came up with probably the best way, but this is my thinking. All right, so you look at these, and you're saying you have rational number solutions. No roots, that's good. That makes life easy. So from that, then I need to determine how in the world I'm going to come up with my solution. Okay. Okay, so let's suppose we have quadratic format. You go to factor. If you were solving by factoring, you had something of this format. Okay. And the next step would be to set, and I'm going to get rid of my parentheses, set each parentheses equal to 0. Let me do it. I knew I was going to do this. Let me just go right to the next step because I think it'll make more sense. So let's go to our solution. Come on, blue. X equals negative 4. I took the first one. X equals negative 4. And let's make this fit x equals 0. Okay? I'm trying to get to x equals 0. Would you agree I would add a positive 4 to both sides? And I end up with this. And my blue is gone. X plus 4 equals 0. See, the problem is we have to think backwards to figure out the factor that gave me an answer of x equal negative 4. So therefore then, do you see how, let me use red here, do you see how this factor must have been an x plus 4 to give me an x equal negative 4 answer? And then in the second one, your x equals 7/5. In this one, you got to move the 5. Multiply both sides by 5. And you get 5x equals 7. And then you got to move the 7. And again, some of you guys in your mind, you can see this right away, but this is a math way of getting there. You get 5x minus 7 equals 0. So do you agree now I'm sticking the 5 here, and I want the back to be a negative 7? And that would have been the root that produced the 5 equals 7/5. And therefore now, that's my answer if they're okay with it being in factored form. If they want it like ax squared plus bx plus y equals 0, what would you have to do? Multiply it out, right? You follow? If they want a squared, just like the standard form a squared, you'd have to multiply that out. All right. The imaginary one, unfortunately, I'm out of time with it, which is a pain. Which this one becomes a little bit more complex. You're going to have to look at the book on that one because my time is gone. I am sorry. I can't do it in 10 seconds. All right. Be careful with your homework. Use it to get things figured out. Last topic tomorrow.